Again, it's going to be a full house. Grab yourself a seat. Welcome. Get a drink. We're going to get started in a few minutes here. A couple of seats down in the front. Everyone's favorite. Welcome to NSMeetup. All right, engineering at work. Okay. How's everybody doing tonight? Woo! Who's ready for the Super Bowl to be over? All right, we got a great speaker for you tonight. This is our first meetup in a long time here at Hotel Tonight, so I'd like to just get a quick round of applause for Hotel Tonight hosting us. My name's Steve Drico. I'm the organizer of NSMeetup. Quick show of hands, how many people is this their first NS Meetup? All right, lots of newbies in the house. Let's give a round of applause to the newbies. Wake everybody up. Welcome, NS newbies. Well, we meet every first Wednesday of the month to talk about iOS, open source, mostly Objective-C and Swift programming topics. If you have a topic that you want to hear about or you're interested in giving a talk, like Tim, just come up and see me. I'd love to hear what you'd like to speak about, or if you have a product or an open source library, or you just want to hear about something, please, we're always looking for speakers, and this community doesn't run itself. So really appreciate your enthusiasm. Thanks for coming out. There's drinks in the back. There's a recycle right next to it. If you need to go to the restroom, it's just on the other side of the elevators that you came in. Instead of making a right out of the elevators, make a left, make another left, and you'll see the restrooms. We're going to be here till 9 tonight, and with all the housekeeping in check, I'd like to introduce tonight's speaker, Tim Johnsen.
All right. Hello, everybody. Welcome. I'm going to talk tonight about link handling on iOS. Yeah. This is a topic that's very near and dear to my heart. As Steve mentioned, I am Tim Johnsen. I'm the iOS lead at Flipboard. I've been at Flipboard for about 4 years. Been doing a lot of iOS there, and I also work on side projects under this name, Tjo. The reason I include this on this slide is that I'm going to talk about things I work on at both of these organizations later on in this presentation. So what do I mean by link handling exactly? It's sort of a weird term on iOS, not something that you hear all the time. So what I'm really going to be talking about tonight is how you can use some of the technologies that are available in iOS to make your apps operate or interoperable with other apps. So I'm a big fan of having apps work better together, not just be little islands into themselves. And so I'm going to be talking about a few technologies that help you have apps interoperate with one another. I'm going to be talking about three things specifically. First is URL schemes. If you've been an iOS developer for a while, you've probably heard of URL schemes, so that might be covering stuff a lot of you have already heard, but I'm also going to talk about some of the changes that happened to URL schemes and why they happened in iOS 9, because there were some pretty big changes. I'm also going to be talking about universal links, which are a fairly recent addition to iOS and are pretty cool. But having implemented them at Clipboard, I'm also going to talk about some of the pitfalls that you may run into if you implement them in your app. I'm also going to talk about Opener, which is a personal project that I worked on in the middle of last year. It predates universal links by a little bit. So getting started, I want to talk a little bit about URL schemes. If you're interested, this is the link to the documentation on URL schemes, and Apple's documentation on URL schemes. So first of all, URL schemes have been around for a really long time. I remember working on my first iOS app way back in the day, and they were there. So it's not exactly a new technology. They're really handy because you can check if they're available. You can actually see if a URL scheme is present on the device, which is not the case with universal links. They're very easy to configure. It's all client-side. You don't change anything on a server to implement URL schemes. And as I mentioned earlier, they made some pretty dramatic changes to them in iOS 9 that I'm going to cover. So what is a URL scheme? Originally, I was just going to kind of launch into this, and I was like, well, maybe not everybody knows what a URL scheme is. So here I have two URLs. This is a web URL and a URL that opens an app specifically. These are both URLs for this very event, actually. And this is the scheme, the very first part of the URL, basically. Commonly for web URLs, it'll be HTTP or HTTPS. And for app URLs, it'll be something that you declare, as I'll get to later. To talk about a couple more components of a URL, this is the host and this is the path. These are much less important for the remainder of this talk. I just wanted to point them out. There's also a query and a bunch of other pieces you can get to. In implementing URL schemes, there's really just two steps. It's very simple. The first thing is in your app's info key list, you have to add a CF bundle URL type. And this is the scheme that your app ends up responding to. So I'm now responsible for foobar : $URLs on the device that this app is installed on. So you add the scheme to your info key list. And the second thing is you implement your application delegates method for handling URLs as an input. It's important to note that the signature of this has changed a few times since iOS 2. I think there were actually like 3 different signatures for this method with various different things. There was one that had like an annotation on the end. So if you're working back in older iOS versions, you should look at whatever the method signature is that's relevant to the version of iOS that you're working with. And then you basically take your URL and you can pull it apart into pieces. In this case, I'm getting a synthetic kind of host ID from the end of it and handling it. It's really useful in these to kind of isolate the code that actually shows the UI from a URL scheme, because if you plan on implementing universal links later on, it's really easy to be able to share them. In fact, in general, with URL schemes and universal links, it's super handy to just share as much of the URLs as you can. It makes your life way easier later on. But a lot of apps that have implemented URL schemes historically have very different formats for their URL schemes versus their web URLs, unfortunately. So to use a URL scheme, it's also pretty simple. You have to do a little bit of work as a client of a URL scheme, as somebody who's about to use it. So for example, this is a hypothetical method that opens a Twitter user, and it tries to launch that Twitter user in the popular Twitter client Tweetbot. So here, you use this can-URL method to determine if the Tweetbot URL scheme is available. If it is, then you can open that URL and it will actually launch Tweetbot. So that's what I'm doing here. If it's not, you can direct users to the web. So I'm just formulating web link and firing that off here. So that's how you use them. Pretty simple. I believe if you fire a URL for a scheme that the OS doesn't respond to, it just doesn't do anything. It's like a silent failure, which is unfortunate, so you need to handle it carefully. So in iOS 9, URL schemes changed a bit. In iOS 8 and prior versions, you could call CanOpenURL on any URL, but in iOS 9, they're a little bit more limited. This is a link to a WWDC video from this past year in 2015. This is not like, they're not talking about some crazy feature of iOS in this video. It's actually about privacy and security and apps. But this, to me, was actually one of the most interesting videos from DubDub this year. They cover a lot of the security policy changes in iOS and why they've made them. So if you go to the 8-minute and 33 mark in this video, you'll see they kind of cover what I'm about to talk about here. But the first thing is that you can no longer call CanOpenURL on arbitrary URL schemes in your app. Any URL scheme that you want to call CanOpenURL on, you have to declare in your info list under this ls application queries schemes array. If you don't include it here, you will get unreliable results. I actually don't know if it returns no or like a random value, but you won't get the correct value, whatever it is. So you are basically forced to declare the URL schemes that your app wants to look for before you submit the app. The reason that Apple did this is that there were a whole bunch of apps prior to iOS 9 that actually used the availability of URL schemes on an app to like fingerprint users and also to target ads at them. So they would look around and see like, oh, okay, this user has all these apps, so we can target things at them based on that, or we should not target an app that they already have installed. So Apple was like, hey, the apps that users have installed are none of your business. So they limited it in iOS 9. If you're linked against iOS 8 or before, but running in an iOS device that runs iOS 9 or above, the OS enforces a limit of 50. So the first 50 URL schemes you call CanOpenURL and it will return reliable results. But the 51st one, it will no longer return reliable results on. So that's one change. Second thing is, and this was a bit of a shocker to me when I discovered this, but no matter what, if you call CanOpenURL in iOS 9, your app will log spew, whether or not the scheme you're calling it on is included in ls application query schemes. This is another thing that I believe is undocumented, actually. It's in that video that I posted the URL to, but as far as I can tell, this isn't in the docs anywhere. So you can see here, I made 2 separate calls to CanOpenURL Instagram : /. The first one, I don't have ls application query schemes, and it actually has an error message. So that's a legitimate failure, like you will get invalid results. But here, I actually did include it, and it says, failed for URL Instagram, but the error is null. And that actually means you did the right thing, which is kind of bogus. I don't know why they did this. It's really annoying if you call CanOpenURL a lot. Let's see, I actually opened a radar for this, and Apple closed it as behaves as intended. So I think that they're trying to discourage people from using CanOpenURL, which makes a lot of sense because they're worried about their users' privacy. So I'm not going to argue with that, but it's kind of annoying. I would suggest within reason caching the results of CanOpenURL if you can, so that you don't get a million calls to it logging. But yeah, so changes to CanOpenURL. Also, if an app attempts to launch another app via a URL scheme, the very first time it happens, an alert pops up. So you get basically a warning. And this is also to protect user privacy. A user can prevent one app from opening another via a URL scheme. So another change. Some best practices. If you're going to, and this actually goes for basically any URL manipulation on iOS these days, but there's this class that was introduced in iOS 7, I believe, called NSURL components. I can't tell you the number of like custom one-off URL formatters I wrote while developing for iOS, but NSURL components is like a system-provided URL formatter. It handles encoding, it handles like all kinds of stuff. So I highly recommend relying on that for formatting URLs and not just appending strings and then generating URLs with it, because that leads to kind of subtle, hard-to-fix bugs. So I would recommend using those for URL schemes. And I mentioned this earlier, I would recommend sharing as much as you can. Share your components of your web URLs with your native app URLs that come in via your custom URL scheme. This will save you headaches later. So for example, like Twitter's app and Twitter's web URLs have the same identifiers on the end, and that makes it very easy to translate one URL into another. If the identifiers are different or formatted differently, then you have to perform some sort of translation from one URL to another, which can be a bit annoying. I would also highly recommend, if you're going to implement a URL scheme, implement it in a conventional way. There's a few ways that people commonly implement URL schemes. The first is by replacing the scheme of your web URLs with whatever your custom URL scheme is. So actually all of Google's apps do this, which is really easy. If you see a Google URL and you want to open it in the Google app, just replace the HTTPS with whatever the app's scheme is and it will work, which is nice. Quora also does this. Another way to do it is X-callback URL. X-callback URL is an open standard that's been around for a few years, but it's a kind of a well-formed way of intercommunicating between apps. They even have a registry, so if you build an app that supports X-callback URL, you can add it to the registry. In fact, my app Opener, which I'm going to talk about later, uses X-callback URL. That's how its URL schemes are implemented. So X-callback URL is nice. And finally, if you're building a URL scheme, I highly recommend that you document it so that other people can benefit from it. A lot of developers will implement URL schemes, but then not actually publicize how they work. And if we want to make apps work better together, it's better to kind of share the love and get the information out there so that people can use your URL scheme, launch your app when the time is right. So document your stuff, highly recommended. Next thing I want to talk about is universal links. So this is the link to the documentation on how universal links work. Universal links were introduced in iOS 9, so they're a very recent thing. And they're sort of treated as a successor to URL schemes in iOS for the most part. The two coexist for now. I wouldn't be surprised if Apple maybe tries to kill URL schemes in the next few years because of the privacy concerns that I outlined. But for now, you can implement both if you choose. They're secure, they're privacy-minded, so you basically, if you use universal links, as a developer, you have no idea if the URL went to Safari or if it went to another app, and you don't get any notion of what apps are installed on the user's device if you open URLs using this. And it also requires an agreement between the client and the server. So in order to use universal links, you actually have to modify a server component in order for basically for the client to open web links in native apps. So you're gonna have to do some server work. It's very simple. As long as you can talk to your ops person or you are your own ops person, that's pretty easy to do. So the way that they work is really easy. So you call canOpenURL in an app. This is your app code, and this is iOS doing stuff. You call OpenURL, and then the OS decides, based on the state of all the apps that it has installed, whether it should open Safari or whether it should open the app itself. You would think that the only criteria for opening the app itself is if an app is installed that supports universal links, but from the pitfalls I'm going to talk about later, that's not the case. You may actually have an app installed that can handle a universal link, but it won't be open for a variety of reasons that I'll cover. So implementing universal links, first thing you have to do is you have to own the server that's associated with your app. And you have to put a file called an Apple App Site Association file at the root of your host. So this is a sample Apple App Site Association. I have two sample apps here. I've got my foobar app, my production app, and my debug foobar app. And then you declare the paths that are supported by universal links in your app. So in this case, my app can open foobar.com/post/anything, and the debug version also opens this special format. You can also do exception rules in here. So if you say the capital word not and then some path, it will ignore that path. So this is how you declare basically on the server what URLs your app should be capable of handling. The weird thing is that there's these identifiers at the front. When I was going to implement this, I implemented universal links in Flipboard. I was like, where do these come from? I have no idea. I don't really see these things very often. You can find them in the provisioning portal. So if you go to your app identifiers, each of these identifiers is present in the provisioning portal. So you should be able to get to them there, or if you're scratching your head trying to figure out where they are. Next thing is you have to update in the provisioning portal. You have to add associated domains, and also in your app's local entitlements file. If you don't have an entitlements file, you need to create one. If you do already have one, you have to add an entry for app or associated domains to it. The easiest way to do this is to go to your app's capabilities tab and flip the associated domains switch, and then fill in the data. If you've worked with Xcode before, you know that like magical fix issue buttons might shoot you in the foot though, so you can also do it manually. I'm happy to explain how to do that if anybody wants to know afterwards, but this switch will usually get you there. And then you have to implement your app delegates handler method. This is very, very similar to the way URL schemes work. Oddly enough, it's the continuity handler method, which is used for a bunch of stuff now. It's not a dedicated method just for handling universal links. It's like all continuity or handoff callbacks go through this. So if you have a watch app or you do like desktop web handoff to your app, it'll all go through this method. So in order to do this, you have to check the activity type that's incoming. It needs to be NS user activity type browsing web. That means that you're receiving a universal link or a web link. And then, similar to URL schemes, you actually just dice apart your URL, get the parts that you need. So here I'm doing some very simple validation that this is a post URL from the web, and I get the identifier, and then and this is key, I reuse the same method that I used for URL schemes, so I didn't like duplicate a whole bunch of code. So I highly recommend trying to share as much code as you can between universal links and URL schemes. Another interesting part of this is that if your app does happen to be launched with a universal link that it's incapable of handling, you have an emergency exit. If you call OpenURL with a URL that your app is supposed to handle, it actually goes to Safari. So if you call OpenURL on your own app with a URL that your app is supposed to handle, it won't like relaunch your app or recall this method. It actually just goes to Safari. So if I end up with a URL that I'm incapable of handling, I kick out to Safari here. Yeah, so that's it. That's what it takes to implement them. To use them, it's even easier than URL schemes. It's actually ridiculously easy because they are literally the same as web links. Universal links and web links are one and the same. So here I have the URL to the Twitter account for NSMeetup. All I have to do is call OpenURL, and this is magically by iOS open in either Safari or Twitter, like I mentioned. One drawback of universal links is that technically, I think third-party clients for things like Twitter could be supported, but the owner of the server for the universal links has a say in who is supported. So, like using universal links, you could not launch Tweetbot or Twitterific or any popular other Twitter clients, which is unfortunate. My app opener allows you to do that, which I'll talk about a little bit later. So, in implementing universal links, I found a lot of pitfalls. I found a whole bunch of issues that were kind of painful. And I ended up documenting them on like a wiki page within the company, but I thought as a very useful part of this talk, I would talk about what they are, because if you go out to implement universal links and you have kind of WTF moments as you're doing it, perhaps this will help you in understanding why whatever's happening is happening. So I want to walk through these really quickly so you can learn from my mistakes and discoveries. The first is that they're not super universal. There's a few problems with them. They work great with OpenURL. So if an app calls OpenURL, the OS kind of URL handling works, and it will either route to the app or Safari. They work with SF Safari View Controller. SF Safari View Controller is great. You should consider using it in your app. Partly because it handles universal links, but partly because they're just cool. And they also work in the Safari app, of course. That's kind of where they mainly come from. But they don't work with UI WebView or WK WebView, which a lot of apps use. So if you're like in the Twitter app and you get its embedded browser, universal links aren't going to work in there because that's a WK WebView. And because most third-party browsers use UI WebView or WK WebView, it also doesn't work in third-party browsers. So if you're implementing universal links and somebody who's using the beta is like, hey, I'm using Chrome, why doesn't this launch the app? That's why. They don't work with anything except for kind of the iOS sacred URL handlers. Second thing is the Apple App Site Association file looks really easy at first, and you're like, cool, I'll just update this file and this will handle whatever paths I need. The trouble with this is that it seems that the Apple App Site Association file is fetched by every iOS client in the wild. So any app or any installation of your app on a device will actually fetch this file. I thought when I was implementing this that maybe like Apple goes out and crawls it periodically and then delivers the Apple App Site Association to clients or something like that. That's not the case. That can pose a few different problems. It seems like Apple makes it so that the clients don't actually update this file very often. So if you make a change to your Apple App Site Association file and expect it to propagate quickly, that will not be the case. It's like on the order of weeks that it refetches it. It doesn't use like standard cache control headers or anything, and there's no way to invalidate your Apple App Set Association file and force it to update. So that's sort of something you run into. Oh yeah, and also it's impossible to debug. You have no idea what state your device is in. So when I first started implementing universal links, for whatever reason, it would not work on my phone, but it worked on my iPad. And it's because for whatever reason, my phone had a cached copy of this file that didn't have the right paths. There's a problem. We didn't have this at Flipboard, but I could also see this where if you have a whole bunch of clients, if you're a very popular app and your server is also very unstable, you could have a problem where basically all of your clients end up DDoSing your server as well, which could be an issue. I wanted to tell also a quick cautionary tale about this. So an example of why this might lead to a problem and why you should have kind of an escape hatch if you're going to implement URL schemes. So Flipboard sends emails to people, like many services do, and in them there are unsubscribe links in the footer. And when I implemented universal links for Flipboard, I was like, sure, /* accept all paths. We can handle any path. We had this nice method for resolving URLs and it worked pretty well. But it did not handle our unsubscribe links. So we got a lot of really upset support requests about that. People would click the unsubscribe links in our footers or tap them, and it would launch our app, and our app would basically show a 404 page, which is not a good experience. If that happened to me, I would be upset about it. So I was like, sure, I got this, I can fix this. I updated the Apple App Set Association file to exclude the path for unsubscribe links. I was like, great, we're good. And then a couple days later, we were still getting reports of it. I was like, really? And it turns out this thing doesn't propagate quickly. So I had a big switch where I could turn off universal links in our app, which I ended up turning on, and then we put out a hotfix that fixed it. So learn from my mistakes. Don't blindly put out all paths. Select your paths very carefully. The next thing, and this one kind of hurts, is that redirects break the behavior of universal links. So if you're in an app like Twitter and you tap the Open in Safari button, first of all, actually one thing that's weird about universal links is Open in Safari in apps actually becomes Open in Safari or like any other app because the OS will just choose whatever app it goes to. So if you tap a URL in the Twitter app or you tap Open in Safari, it actually doesn't direct you, or it doesn't direct the OS to the actual underlying URL. It redirects to a t.co URL, which is Twitter's URL shortener. And that the OS recognizes and wants to open in Safari. And then the t.co redirects to whatever your URL is. So I'm going with my hypothetical foobar URL here. And it just stays in Safari because the OS only really respects the first URL that's directed to. Whereas if you're in like the Messages app and you tap a foobar link, it opens the app directly. So it's kind of like you want to own link shorteners now because link shorteners kind of direct where traffic goes, which is a bit unfortunate. It breaks the elegance of the whole thing because if there's redirects in the way, you don't go to the right place. So that's kind of unfortunate. And this was another weird one to find. Some apps will choose to override the behavior of universal links. So Google has a bunch of very popular apps for iOS. They have 2 mail apps that I'm aware of, Gmail and Inbox, and they also have Chrome, which is probably the most popular third-party browser on iOS. And Google makes their apps link up. So if you tap a link in Google Inbox and the user has Chrome installed, it just goes to Chrome. And people in your company beta testing again might be like, huh, that's weird. I'm using Inbox, and for whatever reason, URLs from this one specific case don't launch the universal links. And that's because Inbox is actually using Chrome's URL scheme, the older technology, to explicitly direct links there. So that's unfortunate. There is a buried internal setting inside of Inbox that allows you to adjust this behavior, but it defaults to Chrome. So yeah, you gotta be careful about that. Whereas if you tap a link in the iOS Mail app, it just will direct you to the appropriate place. Now, grab a drink real quick. This is the 5th and final weirdest pitfall that I found in implementing universal links. So if you've encountered a universal link before on iOS, you may have noticed whenever one is followed into an app, there's a button that shows up in the top right-hand corner. that has basically the host of the URL that landed you in this app. And tapping that goes to Safari, which is a nice thing that Apple did for universal links. The issue with this is that there's this weird memory behavior that the OS has about how links should be handled. So if you tap that button, and then you happen to sometime in the future follow a twitter.com URL that would have landed you in the app, it actually just remembers, oh, the last time the user followed one of these links, they went to the web, so it just directs you automatically to the web. So if a user of your app taps that button and then they start following your URLs, they won't land in your app. The OS tries to act on behalf of the user and automatically go to the browser, which is probably nice for users, but if you're trying to debug universal links, it's really annoying because, again, you have no idea what state the device is in. Similarly, if you encountered a URL in Safari that can be handled as a universal link, this banner shows up at the top. This is nice because it allows users to jump into the app if they are browsing content on the web. But similarly, this button, if you tap it, it records that in the OS. So if a user follows a URL like this again, it remembers, the last time the user encountered a URL like this, it went into the app, so it just goes directly into the app, which is probably what you want, but still, it's like this implicit memory thing. And then finally, this is a little bit weirder. If you're in Safari and you long press on a link to something that can be opened as a universal link, you get a bunch of different options. You can either open it or open a new tab or open in the app. And depending on which one of these you pick, that implicit kind of memory happens again. The OS remembers the last time the user opened it and how, and follows it that way in the future. So if for whatever reason somebody in your company is just having issues with universal links, it's probably one of these 5 things, or it might be something that I haven't found about them yet that causes them to break. That's all on universal links. The last little thing I wanted to talk about is a side project of mine called Opener. If you're interested, there's stickers in the back of the table, and I also have some promo codes that I'll be giving away after the talk. So this is a photo of a walled garden. I think that as developers and as companies creating products, a lot of people kind of focus on keeping users in their app. It's like, we've got these users, we want to keep people in our product for as long as we can, we want them to open our app as long as possible. But I feel like a lot of time that can be kind of self-serving. Sometimes the content that people want to see is not in your app. Sometimes it's in other people's apps. And a lot of people developing apps really don't care about that. They just want to keep people locked in place. And so we're all kind of building walled gardens to some extent. And I'm not a fan of that because I encounter URLs on the web often that can be launched in apps, and for whatever reason, the app just decides to open them in the browser, where I'm not authenticated, where it's a worse experience. So I sought out to tear down some walled gardens. I wrote this app called Opener, a cute little bottle opener icon, with the mission of having users be able to open links from the web in apps instead. I actually launched this the week before Apple announced universal links, which stung just a little bit. But it's still done pretty well, and actually I think universal links have a lot of flaws, as I just outlined. So what is Opener? It looks like this. It's actually got 2 components. I had this idea long before iOS 8, but it really only made sense with iOS 8 because in iOS 8 extensions were announced. So it has an action extension and an app. And basically, the action extension takes a URL as an input, and it gives you the option to open the link in any number of apps, which it can be opened in. So in this case, I have a tweet URL. It can be opened in any number of Twitter clients, which is a limitation of universal links. And then the main app actually uses the contents of your pasteboard. So if you copy a link and then launch the app, it'll show you the apps that can be opened in. So I have a Wikipedia link on my pasteboard, and these are 4 Wikipedia apps that I support. So if you haven't dug into extension development, this is a little bit of a tangent, I would recommend it because extensions are really cool. I think they're one of the neatest things that Apple has introduced into iOS in the past few years. And they're fun to develop, and it's an interesting way to attract new people to your product. So since I launched Opener, 45,000 links have been opened in it, and I'm hoping more people will keep using it. I hope it continues to go up. But what's even cooler, again, it's a testament to extensions kind of being this useful technology, is that 87% of all of the links opened were actually in the action extension. People don't even launch my app. They hardly use the app. Most of the time, they're actually using the extension, which makes a lot of sense because you're on your phone somewhere, you see a URL, you long press on it, and then you can choose to open it from there, which is a pretty nice experience. So the way it's developed, a little bit just to get into this, is there's an engine inside of Opener that takes in web URLs, like I mentioned, and it consults this rule manifest file that I have. Again, not wanting to be a walled garden, the rule manifest file is actually completely open source, and I'm taking 4 requests. I think there have only ever been 4 pull requests on it, but I would love more. So if you're building an app and you want to be able to open web links in your app, feel free to open a pull request. It's pretty well documented as well. I spent a lot of time getting the docs right. And then once it consults that rule manifest, it generates 1 or more app, or 0 or more, I guess, app URLs. So it's capable of taking in a web URL and outputting it as an app URL. That is housed inside of a framework. Frameworks are also cool, introduced recently to iOS. And then that framework is linked into both my app's app and action extension. So most of the code in the app is actually shared. Like 90% of the source files in the app are in both targets and an extension, or in a framework. So yeah, if you want to open a pull request, go for it. I wanted to talk about 2 interesting things in developing Opener that might be useful to you. So the first is that limitation of URL schemes that I mentioned in iOS 9. In iOS 9, you have to declare all of the URL schemes that your app wants to call can open URL on at submit time, basically. They have to be in the info field list. You can't change the info field list dynamically. So the first thing I did, Opener makes very heavy use of can open URL for sorting the available actions and also for showing an app's installation state, basically. So the very first thing that I did was I wrapped open URL in my own category method, open underscore can open URL, and if the user is running iOS 9 or higher, I just made it lie. The app just assumes that every app is installed, which is not great. This puts the burden of knowing whether an app is available or not on people using my product, but it worked for the time being. But then I had a very interesting conversation with a gentleman who works on this other popular app called Workflow, and he pointed out that LS application query schemes, that info field list value, is not documented to have a limit of 50 anywhere. The limit applies to apps that are linked against iOS 8. So apps that are linked against iOS 8 have an implicit limit of 50, but apps that are built with iOS 9, you just have to declare them in LS application query schemes, but you might not necessarily need to have, or you don't need to have 50 or less. You can actually have more than 50. And so originally I assumed, like, okay, well, I'm not going to be able to use LS application query schemes because there's a limit of 50. And when I launched Opener, it supported like 90 apps. But it turns out you can actually have more than 50 in there if you want. I think Opener currently has like 150 in there. So this was really cool, a cool discovery. I would use this cautiously. Apple can still reject you for having bogus URL schemes in there, but it's something you can try if you want to. But then the thing about Opener is that I can actually update the apps that it supports dynamically. That rule manifest, I can update at any time, and it's consumed by the client. So that means I can only update the set of apps that are supported at submit time, or I can only get accurate installation state from the apps at submit time for my app, but I want to update the list of apps dynamically. So what I did was I actually turned my can URL, my custom can open URL method into an email. So instead of returning yes or no, it would return a state where it was like, yes, I definitely can open this app. No, I cannot open this app. And then the third option is I don't know, which means that the entry is not in LS application query schemes. And then I modified the implementation of the method to look a little bit like this, where basically, if I can reliably check the URL scheme, I do, and then I get an accurate yes/no result. But otherwise, I return unknown. And then I modified the app throughout to basically respect this value and kind of do the right thing on a case-by-case basis. So one possible way to handle kind of dynamic URL scheme changes in your app in the future, if you're building with iOS 9 or above, which you probably should be by now. And then the last thing I wanted to talk about is something I've had to do a lot of since I launched Opener, which is reverse engineering URL schemes. So I said about URL schemes, one of my best practices is that you should document them, and a lot of people do, which is really nice. Finding documentation for your URL scheme is great if you need to use it. But by and large, most people who have apps that have URL schemes don't document them, and you have to figure out how they work. so I've had to do this a bunch. So I'm going to give you kind of my top few tips on how to do this. The first thing, which is really easy, this will tell you if the app has URL scheme in it. It will not tell you how it works, but it will tell you if an app has URL schemes, what they are, and that. So if you download an app from the iTunes store, you can take the IPA and change the file extension to .zip, because IPAs are actually just zips. And then decompress the file, and then you can actually get into the app and grab the info key list from it. And if you remember from when I was talking about how to implement URL schemes, the URL schemes that an app supports are just in that info key list. So you can just take that file, get the URL schemes from it. So that'll tell you if an app has URL schemes or not, which is pretty handy. But if you want to reverse engineer how a URL scheme works, you have to do some other stuff. So other very common way of doing it, which is I am extraordinarily grateful to Facebook and Twitter for doing this, but Facebook and Twitter both years ago defined standards for how web pages can include markup that indicates how a web page can be opened in an app natively. So for Twitter, that's the Twitter cards format. So there's Twitter metadata that a lot of very popular websites support. And for Facebook, it used to be called Open Graph, now it's App Links. I think some websites support both. But basically, a lot of web pages include markup that tells you how to open the web page in a native app. So this is an example for Foursquare. Foursquare actually, they document their URL schemes, so you don't have to use this. But you can see that in this page for Ritual Coffee, there's a Twitter app card kind of meta tag for how to open it in the link, or open it in the app, and then also for app links, there's the same thing. And a whole bunch of very popular services use this. This is kind of the easiest way to get at how a URL scheme works in an app, because all you have to do is go to the page. Another way to do it is you can change the user agent in the browser. So if you launch Safari, you go to the web page that you want to reverse engineer the URL scheme for, you can modify the user agent in the developer tools, and then you can hunt in that page for open app buttons. And unlike on iOS, where if you call open URL with the URL that the OS can't support, it doesn't do anything. On OS 10, you get a pop-up that says, hey, your computer doesn't know how to handle this URL. And this also will indicate what the URL is that the page is trying to launch. So this is also a really easy way to do it if Twitter cards and Facebook app links are on the page. And finally, even more craftily, there's no kind of like security around URL schemes. Multiple apps can have the same URL scheme, and whatever the last one that the OS loaded was is the one that gets launched when a URL with that scheme gets fired. That's also a security issue, which is probably why Apple's moving away from them. You can create an app that declares a URL scheme that you want to reverse engineer, and then from another app, you can launch that app. So this is actually how I reverse engineered how Facebook's events URL scheme works. Because in the iOS calendar app, if you plug in your Facebook calendar, it shows a button that allows you to launch in Facebook. And so I created an app that responded to the Facebook URL scheme, and I clicked the button and it launched my app. And I was able to see how that URL format worked, which is kind of handy. And finally, I don't have a slide for this, but I think it is important to note. You can also just fiddle with URLs and try to figure out how they work. Like the format that I told you earlier, where you take a web URL and replace the scheme, that's very easy to do. You'll usually find if it works. You can also kind of guess, which I've done sometimes too. Like if it's a post and there's an identifier for the post, try /post/identifier, and sometimes that'll work. So some experimentation is nice to do as well. So with that, I wanted to say thank you for having me, and I wanted to ask if there were any questions. Yes?
Wildcards. You talked a little bit about saying that you can respond to get slash post / star. Just how much flexibility and is there much regex in there?
You mean for, well, I guess that applies to both URL schemes and universal links. So the question was wildcards, or I guess you're asking about universal links specifically, right? So in the Apple App Site Association, you can declare kind of what the set of paths are that you support. I think that it's not comprehensive regular expressions, is my understanding. I think you can have a path that has asterisks in it, and that defines anything, but I don't think you can do like a full, like, 5 integers followed by 3 letters. That's my understanding. So you can use asterisks, and you can do exceptions using the not keyword, but I don't think it does like the full thing.
Things between slash
Yeah. Yeah. Yes, sir.
Hi, I've actually implemented deep links using branch metrics and using the universal links. I've run into a bunch of the pitfalls you mentioned.
Yep.
So it's very nice to have them documented in one place. I did see a few things I was wondering about. You said the redirects don't work. Can't you add another that redirect into your app links associated domains? Because I think you can add more than one associated domain there.
So the question is, can you make redirects work to launch your app? And you're talking about basically like you can have multiple paths.
So you could have like twitter.com as one of your app links, and then you could have t.co as another one.
Yes.
Maybe you could put in a bunch of other short links.
Yeah. So the issue with that is that what if Twitter is directing you to a T-code, but it ultimately directs to something that isn't owned by Twitter? That's more what I was getting at. So we actually had this situation in Flipboard where basically people tweet Flipboard links that we want to launch in our app. But what happens is when they're tapped, it directs to a t.co, which is not something that we own. We can't add our entry to their Apple App Site Association file, and then it redirects. So it basically bypasses our app. Does that make sense?
Yeah.
Cool.
I also had another question. You said sometimes the universal links don't work in some of the other web views, like the UI web view. What happens when when you click a link there, it just like goes to Safari?
Yeah, so the question was universal links not working with UI WebView and WK WebView. What happens if you tap a link in UI WebView or WK WebView is it just goes to that page in line. That's it. Whereas in SF Safari View Controller, it might actually try to launch the app. And you also, I believe, in UI WebView and WK WebView, you also don't get the nice banner that pops up. Like in Safari, you get a banner that says, "Oh, this can be open in an app. Do you want to do that?" And UI WebView and WK WebView don't do that. So I think that's a security thing too, because you can inspect the view hierarchy of those, and if there is a banner, it's a way of reverse engineering if an app is installed or not. So I think they don't want to do that. Whereas SF Safari View Controller is out of process, so like you can't reverse engineer anything from it. So. Yes.
Do you know if you got one of those failed redirects and then your website had some JavaScript that was like, oh, I just received something, I could try and reopen it in my own app and have that work? Do you think that would work, like using JavaScript to attempt a universal link after a failure?
Well, the thing is that a universal link, the question was, do you think that you could use JavaScript to fall back after a universal link fails and then open it some other way? The thing is that the universal link will never fail because the OS transparently either goes to Safari or it goes to the other app. So there's no like waiting to see if it fails. It'll always succeed. It'll either go to Safari or go to the app. So yeah. Yes.
So one thing that's worth noting is that I think that Apple improved the way they fetch the app association file in 9.3. We filed a bug because we set a bad proxy and tried to fetch the association file, and then we just like cordoned off the device for 5 days. And on like the 6th or 7th day, it fetched the association file. So we filed a bug. They were kind of dramatic about it, and then they said try it 9.3. And supposedly it's better now.
I also filed a radar and they closed the same. So the question was, has the Apple App Site Association file changed? And the answer is yes, it has changed. It seems to be fetched a little bit more frequently than I might have quoted you before, but it's still like multiple days in between fetch times. And we also, as developers, still have zero control over when that is, unfortunately. You'd think you could use cache control headers or something to choose when it is invalidated, but you can't. Yeah.
So, question this time, actually. Do you think Apple is going to crack down in the future on some of the practices around not opening universal links and keeping things in web views or redirects?
So the question is, do I think that Apple's going to crack down on people not adopting universal links in the future? In general, Apple, they are a very security-minded company. That's why they did everything they did in iOS 9, and I think it's great. As far as cracking down on things, I imagine that they will do something. I don't think they can reasonably take away WK WebView, at least. I can see them deprecating UI WebView because it's been a few years and they're pushing people towards WK WebView. But, and I imagine they might also consider deprecating URL schemes or something like that because of all the privacy issues. But there are so many things built on on top of URL schemes right now that I think it would be really hard to do that. Like tons of like Facebook and Dropbox and tons of really big companies use URL schemes to authenticate people. So Apple deprecating that seems like it would be really heavy-handed, and it would probably cause a lot of trouble for developers. But yeah, I mean, I imagine they'll continue to kind of improve the security of it all. Any other questions?
All right, let's give him a applause. Well, we're going to be here till 9 o'clock tonight. If you guys enjoyed this topic or you're interested in giving a talk, please come see me. And also, if you're interested in hosting NS Meetup, please come see me. As you can tell, we're starting to get over capacity. Too many great talks on the schedule, I guess. Good job, organizer. All right. Okay, well, enjoy yourself. Thanks for coming, guys. We're going to have some more beer out there in about 2 or 3 minutes, making sure it's ice cold. Thanks. Bye. I'm worried there's going to be an after. Okay. I'm worried that somebody I'm doing all this.
Okay, so I can go. I should go a little bit. I guess. Yeah. I know. What we do is basically like we want users to install our app. Basically, we stash and then we get the stream later. Once the app is open, there's a lot of stuff. So sharing exactly, yeah. So we were implementing branches early. Yes, so we created an LSM script in the community. You install an app from the link. Funny story. Yes. Yeah. I also Yes, right. Yeah, we were in the same group and we had dinner. And I was like, yes, yes. And then you ended up I'm pretty sure we're going to read that Facebook. I do very hard things.
Yeah, she was on the car too. Yeah, that's usually what I do. Yeah. Like, otherwise, I would totally do this. That's true. But I'm not yeah, well, the reason is we were going to get